Yeah, you're just going to look at finding the gradient of a line between 2 points. So basically, the gradient is just the rise over the run. So if you think of anything outside that's sloping, you have things that are really steep and you have things that are not so steep. And you have things that are just in between. So if you look at these 3 different examples, like this one here, it goes across more than what it goes up. We define this as the rise and this is the run. This one's the rise, this is the run. This is the rise and this is the run. Now, when the rise is smaller than the run, then the thing is not so steep. So say that was equal to 2 meters, but this was equal to 6 meters, then the rise over the run, if you compared the rise over the run and we looked at that fraction, that would be 2 over 6, which is 1 to 3. So what that means is for every 1 unit I go across, or every 3 units I go across, I go up 3. It means wherever that slope is, it's always in this ratio, 1 to 3. So it's always in that fraction, 1 to 3. Okay, and that's basically how it would slope. That's called its gradient. Now, if you went up a lot steeper than what you went across, so for example, say you had something looking like this, and you went 2 meters across, but 6 meters up, then if you looked at the rise compared to the run, that would be 6 over 2, which gives you 3. And you notice that it is actually a bigger number than the last gradient. So it's 3. It's 3 on 1, which is 3. And that's why it is really quite steep. If the gradient's bigger than 1, it will go up bigger than on an angle of 45 degrees. Say this one here, this one looks like the rise and the run are pretty much the same. So when you're looking at the gradient here, that would be 3 on 3, which is 1. Okay, so the gradient is just your slope, and it's about comparing the rise to the run. So to actually calculate it is just the rise on the run. Now, when we go to a number plane, if we have like our 2 points, if we want to get the rise and the run, we need a triangle. So if you do that, and then you count how many spaces, 1, 2, 3 there, and then let's say that was 1, 2, 3, 4. You count the spaces here, that's 2. Then the gradient of this line would be 2 over 3. Okay, let's just have a look at another one like that. So we might just plot these points. So let's go 4, 3, and B, which is -1, -2. So we go 1, 2, 3, 4, and then we go up 3, so we're here, and then we go -1 and -2. So if we're looking at the slope of that line that goes between those 2 points, A and B, then the first thing we really need to be able to do is to draw a triangle. Now looking at that, this is the rise and this is the run. Now you need to count the spaces. The rise is 1, 2, 3, 4, 5, and the run is 1, 2, 3, 4, 5. So they're basically the same. So the rise on the run, that will be your gradient, which will be 5 on 5, which equals 1. Now a symbol for the gradient, the symbol is just equal to m. So just write that down in your books. And just one other thing, when we are on a number plane, basically if we're going downhill, that will have a negative slope. And if you're going uphill, that will have a positive slope. Okay, so this is the rise, and this is the run. The rise, and this is the run. So a way to remember this, if it's going downhill, it's negative. Going uphill, it will be positive. So this one is negative, this one's positive. So if we have like a slope going like this, and if that was 4 and that was 8, once we assign and put it on a number plane, then that gradient is 4 on 8, which is a half. So the gradient would actually be minus a half because it's going down. Because what's happening is that x values will be increasing. You can see that the thing is going down, y would be decreasing or getting smaller. And until you actually graph lines and have a look at it, you'll understand really then why that one is negative. This one here, see, as you're going across, the y value or the rise is going up. Whereas this one, when you're going across, the rise is going down. So let's just look at, sorry, I just want a positive one. So let's just say that was 5 meters and 10 meters. Then the gradient there is positive because as we're increasing, the thing is going up. So it's 5 on 10, which is 1/2. All right, and finally, if you had it on a number plane, and we had A, which is 1, 2, so we go 1, 2, and B, which is 4, 5, so 1, 2, 3, 4, 5, and 3, 4, 5. Okay, so go across 4 up to 5, draw your line. Okay, so if you were looking at that, basically what you've got to do is you've got to do the rise on the run. Now, that is actually a positive slope. And if we look at the spaces, we go 1, 2, 3, and the run here is 1, 2, 3. So the gradient would be 1. But if I put it and I make it go the other way, I'm just going to give you one that is the other way. So let's go 1, 3, and we're going to get the gradient between 1, 3 and say 4, 1. So 1, 2, 3, so that's there. 1, 2, 3, 4, that would be 4, 1. It's going like that. Can you see that it is going down? So it will have a negative gradient. Let's draw our box in. So the spaces here is 2, 1, 2, 3, 3. So the gradient is 2 over 3, and it would be a negative because it is going downhill.